was asking us, does y represent a function of x? Is that correct?
I believe so. Yes.
Okay, so when was it in the previous notes?
Yes, it was.
Okay, so all I wrote, and we'll go back and check in a minute, I did not recycle them. So we have to write y equals plus or minus the square root of 4x, which can be rewritten as the plus or minus to the square root of x. And then I said, for x equals 1, I get two y values, which is for, if I show that for one x value, I get two y values, this is not a function. So now if you put 0, you will get only 1, which is 0. So you have to show that for one number, that's sufficient for one number. Now I can also show for x equals 4. The square root of 4 is 2. 2 times 2 is 4. So for x equals 4, I get y equals negative 4 and y equals 4. But there is no need. It's sufficient to show that for one x value, I get two corresponding y values. Therefore, 4x equals y squared is not a function, is a relation. That's why I picked a number to show. In other words, with those bubbles, for x equals 1, I have a correspondence of y equals 2 and negative 2. And this is not acceptable when it comes to functions.
Yes, ma'am.
So that was the explanation. Did I write something else that wasn't clear?
Yeah, I just want to be clear. You didn't explain the X. That's all I was.
Okay. Okay, very good.
I got it.
My pleasure. Next question. Anything else that you would like us to work on before we start? Anyone else? Other questions? Hunter, anything? Do you have anything for me? Bailey, Katie, Emily, anybody?
No, I think I'll stay after to ask you my questions.
Of course. Anyone else, or we continue? Okay, in that case, I wanted to continue with a word problem here and then continue towards the end of chapter 2. Okay, I'd like to look at a problem like this. A word problem in which transformations are useful. We can discuss them. So we have this function in problem 127, and again, this is on page 298. So we are given a function which is f of x equals 2.9 the square root of x plus 20.1. Hi, Monica. Unfortunately, I was asking you to show up at 6 p.m. I started a new class. I have a class from 6:30, so you're more than welcome to stay, but I will not be able to help you during the class time. So I have another option if you'd like tomorrow at 5 p.m.
Yes, that'll work.
I'm so sorry. I started my class.
No, it's okay.
That's okay. I will see you tomorrow at 5, and the link is on the homepage Tuesdays and Thursdays. Not this link, it's the Tuesday, Thursday link at 5 tomorrow. Thank you so much. Thank you. My apologies. Okay, so we are looking at this function. Let me share my screen again. So 2.9 times the square root of x plus 20.1. And the graph is given here. We're going to talk about the transformations in a minute. It says f of x represents a median height. So I'm going to take notes. Median height. Okay. In inches. Then x is the age in month. So x, age in month. Perfect. I took my notes. I have the function. I have the what f of x represents. I have what x represents, and I have their measurement units. Good. Then Describe how the graph can be obtained using transformations on the square root function. And of course, in order of operations. Can anyone, so we know that the base function is the square root of x. We know that, and they're also telling us. Can anyone tell us what is the first transformation that is applied to the square root of x? And what is the last transformation that is applied to function from number 2? So when you look at the function, 2.9 times the square root of x plus 20.1.
Square root of x plus 20.
We can never do that because this is a way more powerful operation. By the order of operations, we can never add first if we have something else involved. So therefore, the first operation is, and also the first transformation is, please, anybody?
2.9 times the square root of x.
Excellent. 2.9 times the square root of x. What does it do to this function? So it's the y value, because there is no change in x. So it's the y value multiplied by 2.9. What does that do? What transformation is that when we multiply the y value by 2.9?
Shift.
The shifts are either plus or minus, not multiplied. Plus or minus, I mean minus and plus horizontal, not multiplication. Anyone? When we multiply y by 2.9, what do we do? What happens? When we multiply y by 2.9, what happens to the graph? Which transformation is that? Anyone remembers from last time? When we multiply y by a number greater than 1, what transformation is that?
Stretch.
Yes, vertical stretch by a factor of whatever that is. Good. So we established that. Vertical stretch by a factor of 2.9. Good. Now, the final answer or the final function, which transformation we apply to this function to get this one? Please try, even if you're wrong, it's okay. What do you think? Which transformation is this?
So does that mean it moves up by 20.1?
Up. Very good. Up by 20.1. Excellent. Good. Now let's look at part B. Great. Thank you so much. According to the model, what is the median height of boys who are 48 months? Use a calculator to run to the nearest tenth of an inch. Then they say, ta, ta, ta. We'll come back. So what do we do when we are asked to find the median height for boys that are 48 months old. What are we asked to do? We're asked to find the median height for boys that are 48 months old. What does that mean? Anyone, please? What do we need to do to find the height, the median height in inches of boys that are 48 months old?
Do we replace the X with the 48?
Absolutely. So all we have to do is f of 48. Very good. Excellent. Thank you. So what I highly recommend, because we may have to evaluate for more than just one value, I highly recommend go to y equals, clear whatever you have, and punch in 2.9 times the square root of x outside plus 20.1. Plug it in. Plug in the function, look at it, make sure it's entered correctly. Then, with second and table, enter 48. Very elegant, very simple. So they want 2 decimal digits, they said. So it's 40.19. What is the measurement unit? What is the measurement unit of 40.19?
Inches.
Excellent. Thank you very much. Inches. Now let's read on. So we determined their height at 48 months old. Now, the actual median height for boys at 48 is 40.8. So I'm going to write actual is 40.8 inches. Let's see. How well does the model describe the actual height? So the actual height has 0.80 and this one has roughly 0.2. So there is a mistake, if you want, or an underestimation by 0.6 of an inch. Would you consider this model appropriate with some minor error, or would you say, no, the model doesn't work? What do you think? Is a 0.6 error acceptable? 0.6 of an inch, roughly? Would you accept it? Or would you say, no, the model is not good? Please say something. Anybody, please?
I feel like the 0.6 inch of an error.
You're okay with it?
Yeah.
So am I. I think it's a good model. Very good. See? Use the model to find the average rate of change in inches per month between birth, which is 0 months, and 10 months. Round to the nearest tenth. So they want only 1 decimal digit now. So between 0 and 10. So the average rate between 0 and 10 months. Can anyone refresh our memory on the average rate of change formula? What is the formula for the average rate of change? The average rate of change. And this is between 0 and 10. But first, the formula. Can anyone refresh our memory on the formula for the average rate of change? Please, anybody remembers the formula for the average rate of change? Please, anybody? Anyone, please? Bailey, do you remember the formula for the average rate of change?
What was the question?
The average rate of change, the formula for the average rate of change. So we can determine it.
Is it f of b minus f of a over b minus a?
Excellent. F of x2 minus f of x1 over x2 minus x1. Very good. Excellent. Perfect. So I have to determine, so this is basically 10 and this is 0, x2 and x1, but I have to determine f of 10 and I have to determine f of 0. No problem. So the denominator is 10. Excellent. Good. So now I'm going to share my screen again and go to the calculator. I know the function is there. All I have to do is plug in 0 and plug in 10 because the function is waiting. So for 0 is 20.1 and for 10 is 29.2. I want to see to the side. 29.271. Okay. Good. Excellent. So this is the average rate of change. Let's calculate it. So 29, so this is 10. So 29, so this is 9.1. So when we divide by 10, we get 0.91. They wanted to round up to 10th. So now I'm going to just leave it as 0.9. Now the question is, what is the measurement unit? Can anyone please give us the measurement unit? The measurement unit for a rate of change. Anybody remembers how we determine the average rate of change? It's a measurement unit for the average rate of change. Anyone, please? Somebody who didn't say anything today? Imani, would you like to answer? It's okay if you're wrong. We are trying to discuss the topics here.
Is it output over input?
Exactly. So let's go back. What was the output measured in?
Inches.
Perfect. And what is the input measured in? So indeed is in inches per month. Excellent. Okay, final question here. Use the model to find the same thing between 50 and 60. Fine. Not a big deal because I already have the function. It's already waiting. I just need to plug in 50. I need to plug in 60. I just need to copy. So for part D, the average rate of change between 50 and 60. F of x2 is 42.56 minus 40.61 divided by 60 minus 50, which is 10. We use exactly the same formula. F of x2 minus f of x1 over x2 minus x1, which is 10. Very good. So let's see what we get here. So let me just make sure that I copied the numbers correctly. Did I copy for 50? Yes, I did copy, and then 40.61. Okay, perfect. Good. So the denominator is 10. So we have a 5, we have a 9, and we have a 1. Oops, not two decimal digits. So there's a 5 from 5 and from what? Yes, 1.95. I divide by 10, I get 0.195. And if they want only one digit, it will be 0.2. Again, can anyone give us the measurement unit for 0.2? What is the measurement unit for 0.2, please?
0.2 inches.
Careful. It's a ratio. It's the same type of ratio as this one is. And if it's a ratio, it has to have the measurement unit of the top divided by the measurement unit of the denominator. So it's the same thing, inches per month. Is that clear? Good. So let's see if there is anything else here. If not, we move on. So how does this compare to the answer in part C? And how is the difference shown by the graph? Okay, so between 0 and 10, do you see this is the slope of the line? Between 0 and 10. Very steep, right? But between 50 and 60, this is the slope of the line. Meaning, as you see, the rate of change is almost 1 inch per month, which means they grow faster at the age between 0 and 10. And they continue to grow, but much slower than it was between 0 and 10. So this is still 10 months, and this is still 10 months, but this is much faster because the average rate of change, the slope of this line, the secant line, right, going through this point and this point, much steeper than this one. About 5 times steeper. How do I know? Well, 0.2 times 5 is roughly 1. So about 5 times as fast they grow between the ages of 0 and 10 months versus between the ages of 50 months and 60 months. They still grow, but much slower. Any questions on this problem? Anyone? Any questions on this problem?